winter of 1945, the Germans believed they had finally exposed America's weakness. They'd smashed supply lines, captured fuel, scattered maintenance crews, convinced the U.S. Army would freeze in place. And for a moment, they nearly succeeded. But what happened next is something German planners never accounted for: American improvisation. In the darkness outside Stavelot, one sergeant rebuilt an entire carburetor from mismatched scraps. German, American, anything he could find. And in doing so, kept a supply lifeline alive that should have died that night. This wasn't just mechanical genius. It was the kind of practical freedom Germany didn't understand and couldn't defeat. And once you hear this story, you'll see why the Ardennes was lost long before the shooting stopped.
January 23, 1945. The Ardennes Forest, Belgium. The snow had stopped falling 3 hours before dawn, leaving behind a silence so complete that the creak of frozen metal carried for half a mile. Along the road between Malmedy and Stavelot, 18 vehicles sat motionless in the pre-dawn darkness. Supply trucks, fuel tankers, and ammunition carriers that had been pushing supplies forward to Patton's Third Army since the counteroffensive began. The temperature hovered at 14 degrees Fahrenheit. Ice had formed inside the radiators. And somewhere in the column center, beneath the canvas tarp of a maintenance half-track, Technical Sergeant Raymond Kowalski of the 407th Ordnance Media Maintenance Company was doing something that would, in the next 72 hours, prevent the collapse of an entire supply corridor and keep 3 infantry divisions from running dry. He was building a carburetor from scrap metal. This was not supposed to happen. The United States Army had entered the war with a logistics doctrine built on standardization, replacement, and overwhelming material superiority. When equipment failed, it was replaced. When parts broke, new ones arrived from depots stretching back through France, across the Channel, and ultimately to the industrial heartland of a nation producing war material on a scale never before witnessed in human history. By January of 1945, American factories were turning out 60,000 aircraft annually, 45,000 tanks, and enough trucks to motorize every division in the European theater twice over. The system worked because it was designed to work, a machine of such scale that individual breakdowns became statistical irrelevancies absorbed into the vast momentum of American production. But the Ardennes had broken that system. When German forces launched Operation Wacht am Rhein on December 16, 1944, they had done more than surprise the American First Army. They had severed supply lines, captured fuel dumps, overrun maintenance depots, and scattered ordnance companies across 100 square miles of frozen forest. The 407th had been stationed near Spa when the offensive began. By December 18th, they were retreating westward, abandoning 2/3 of their parts inventory and all of their heavy material. Machinery. What remained, the portable welders, hand tools, and whatever scrap they could load into 3 half-tracks, became the entirety of their operational capacity for the next month. They had been operating in survival mode ever since, cannibalizing destroyed vehicles for parts, improvising repairs with materials never intended for military use, and keeping the supply columns moving through sheer mechanical ingenuity, while the official replacement system struggled to reestablish itself through roads still choked with retreating units and advancing reserves. Raymond Kowalski had been a mechanic before the war. He had worked in his father's garage in Hamtramck, Michigan, a Polish neighborhood north of Detroit where men fixed things because replacement was expensive and pride demanded that broken objects be made whole again. He had learned to work with what was available. When the Depression deepened and parts became scarce, he had learned to fabricate. By the time he was drafted in 1942, he could rebuild a transmission with hand tools and patience, and he understood machines not as assemblies of interchangeable components, but as systems of relationships, metal and motion and heat, each part affecting the next, each failure offering clues to a solution that might lie outside the manual. The problem that morning was carburation. 18 vehicles in the convoy were GMC CCKW trucks, the workhorses of the Allied Logistics Network, commonly known as Jimmy trucks, capable of carrying 2.5 tons across any terrain that qualified as road. They ran on GMC 270 inline-6 engines, simple and robust, designed for reliability over performance. But simplicity did not mean invulnerability. The carburetors had been failing for weeks. Cold starts in sub-zero temperatures. Fuel contaminated with water that froze in the jets overnight. Dirt and debris from damaged fuel dumps. By mid-January, 7 trucks in this convoy alone had suffered carburetor failure. The 407th had replaced 4 with spares scavenged from destroyed vehicles. The remaining 3 sat dead because no more carburetors could be found. Standard procedure called for requisitioning replacements through the advanced section supply chain. Kowalski had submitted the paperwork 4 days earlier. The estimated delivery time was 10 to 14 days, assuming the requisition reached Liege without being lost in the chaos of rerouted convoys and bombed-out depots. The convoy could not wait 10 days. The Third Army was advancing toward the German border. Fuel and ammunition consumption had doubled. Every truck idled in the Ardennes represented tons of supplies not reaching the front, and every day of delay allowed the Wehrmacht to stabilize its retreat and prepare the next defensive line. So, Kowalski stopped waiting. He began in the wreckage field outside Stavelot, where the German 1st SS Panzer Division had abandoned 24 vehicles during their withdrawal on December 20. Most had been burned. Some had been stripped by other American units scavenging for parts. But among the hulks, Kowalski found a Kübelwagen, the German equivalent of a Jeep, powered by an air-cooled Volkswagen engine. The carburetor was intact. It was the wrong size, the wrong configuration, used German metric threading, and designed for an engine with half the displacement of the GMC 270. It was, by every technical standard, incompatible. Kowalski took it anyway. Back at the half-track, he disassembled the German carburetor and studied its components under a kerosene lamp. The principles were identical. Air and fuel mixed in precise ratios, controlled by jets and floats and Venturi effects that had not changed since the invention of the internal combustion engine. What differed were the measurements. The throat diameter was too narrow, the float chamber too small. The mounting flange configured for bolts spaced 40 mm apart instead of the GMC's standard 2-inch pattern. But the brass jets were salvageable. The throttle plate could be resized, and Kowalski had metal. He had acquired the metal 3 weeks earlier from a destroyed American half-track, cutting away sections of the chassis with a hacksaw because the portable torch had run out of acetylene. The steel was mild, workable, not ideal for precision machining, but sufficient for structural brackets. He had brass fittings taken from a plumbing supply dump in Malmedy, requisitioned without paperwork during the evacuation. Because paperwork had ceased to matter when the Germans were 5 miles away. He had a hand drill, files of various grades, a small anvil, and a ball-peen hammer. He had no lathe, no milling machine, no precision measuring instruments beyond a battered caliper missing its depth gauge. He had time, skill, and necessity. The work took 16 hours. He began by fabricating a new mounting flange from sheet steel, drilling holes to match the GMC intake manifold, and tapping threads by hand with a die set salvaged from the ruins of the 407th's original workshop. The threads were imperfect. They would hold. He machined a new throttle shaft from a salvaged bolt, filing it down until it turned smoothly inside the carburetor body, then drilling a cross hole for the throttle plate using a hand drill braced against his knee. The plate itself came from the side panel of a ration tin, cut and filed until it fit the throat diameter with less than 1 millimeter of clearance. He reamed the German jets to larger diameters, measuring by eye and testing with wire gauges, calculating fuel flow rates based on intuition built from a decade of adjusting carburetors for trucks that hauled auto parts through Michigan winters. There was no manual for this. There was no precedent. The GMC technical documentation provided specifications for replacement but not adaptation, and the Army's ordnance manuals assumed a supply chain capable of delivering correct parts to the correct location within a reasonable time frame. Kowalski was working in the space between doctrine and reality, guided by principles older than military logistics, the understanding that machines were tools built by humans to solve problems, and that problems could be solved if one understood the underlying relationships between force and material and function. By the evening of January 24, he had completed the first hybrid carburetor. It looked like no carburetor ever produced by any manufacturer. German body, American throttle, improvised flange, modified jets, held together by brazing and threaded fittings and the kind of meticulous hand fitting that had disappeared from American industry with the rise of mass production. He installed it on one of the dead trucks, primed the fuel line, and cranked the starter. The engine caught on the second rotation. It ran rough for 30 seconds as fuel distribution stabilized, then smoothed into the steady idle characteristic of the GMC 270. Kowalski adjusted the mixture screw, listened to the engine response, adjusted again. After 10 minutes, he put the truck under load, driving it in circles around the frozen field while listening for misfires or hesitation. There were none. The carburetor held. The engine delivered power. The truck was operational. He built 2 more over the next 48 hours. The Convoy departed Stavelot on January 27, all 18 vehicles running, carrying 40 tons of artillery shells and 12,000 gallons of fuel destined for the 90th Infantry Division near St. Vith. They arrived on schedule. The shells were distributed to field artillery battalions supporting the advance toward the Siegfried Line. The fuel went to tank destroyers and armored reconnaissance units probing German defensive positions. None of the 3 repaired trucks experienced carburetor failure during the trip. One remained in service until March, when it was finally rotated back to a rear echelon pipo for standard maintenance. By that time, Kowalski had fabricated 11 more hybrid carburetors, trained 3 other mechanics in the improvisation technique, and submitted a detailed technical report to the 407th's commanding officer, describing the adaptation process and recommending its use as a field expedient until proper supply lines could be re-established. The report was filed and forgotten. No commendation was issued. Kowalski received no recognition beyond a brief mention in the company's daily log. S.G. Kowalski effected emergency repairs to convoy vehicles, a sentence that carried no indication of the ingenuity involved or the consequences avoided. This was typical. The maintenance companies worked in obscurity, their successes measured not by dramatic battlefield victories, but by the quiet continuation of logistics that made those victories possible. When trucks ran, nobody noticed. Only when they stopped did the system reveal its fragility. But the fragility was always there. The German offensive in the Ardennes had been predicated on a fundamental miscalculation about American logistics. German planners had assumed that the American supply system, for all its material abundance, would prove brittle under sudden disruption. They had observed the American reliance on motorized transport, the long supply lines stretching back through France, the enormous fuel consumption of mechanized divisions, and concluded that a deep penetration into the American rear would sever those lines and paralyze the advance. German forces had been ordered to capture American fuel dumps to sustain their own offensive, operating on the assumption that the disruption would create cascading failures throughout the American logistics network. Trucks without fuel, divisions without ammunition, a modern army immobilized by its dependence on material abundance. For a brief period in late December, that assumption had seemed accurate. Supply dumps were overrun, fuel shortages developed. Units retreated, abandoning equipment and supplies. The roads clogged with refugees and retreating soldiers, making movement nearly impossible. For 10 days, the American supply system in the Ardennes teetered on the edge of systemic collapse, and German commanders believed they had successfully exposed the fundamental weakness of an army that had prioritized quantity over resilience. They were wrong. What the Germans had failed to understand was that American material abundance existed not merely in the volume of production, but in the culture that produced it. The United States had built its industrial capacity on a foundation of improvisation and adaptation, a society where automobiles were repaired in small garages by mechanics who learned their trade through trial and error, where machines were kept running through ingenuity rather than replacement, where the frontier experience of making do with limited resources had been translated into an industrial ethos that valued practical problem-solving over rigid adherence to procedure. The American soldier was not simply the recipient of superior material support. He was, in many cases, a product of that same culture, trained to think pragmatically about mechanical problems, capable of adapting tools and techniques to unexpected circumstances, and willing to disregard official procedures when those procedures failed to address immediate reality. Raymond Kowalski was not exceptional in this regard. He was typical. Throughout the Ardennes campaign, in maintenance companies scattered across Belgium and Luxembourg, similar acts of improvisation occurred daily. Mechanics welded broken axles using scrap metal and portable forges. They repaired damaged transmissions by swapping gears between incompatible models. They kept generators running by winding new armatures from salvaged wire. They fabricated fan belts from strips of canvas and industrial adhesive. They rebuilt electrical systems using parts scavenged from destroyed vehicles, mixing American and British and captured German components into hybrid assemblies that violated every standardization protocol but functioned reliably enough to keep the supply columns moving. These repairs were rarely documented in detail. They appeared in maintenance logs as brief entries, vehicle returned to service, without explanation of how service had been achieved or what obstacles had been overcome. This was the hidden strength of American logistics, not the factories or the supply ships or the vast stockpiles of equipment, but the men who kept that equipment functioning when the official system failed. The Germans had planned for material disruption. They had not planned for human adaptability. And in the frozen forests of the Ardennes, that adaptability became the difference between paralysis and continuation, between a shattered supply line and one that bent but did not break. The 407th Ordnance Medium Maintenance Company had entered the Ardennes with 83 vehicles and 214 men. By the end of January, they had lost 19 vehicles, suffered 42 casualties, 12 killed, 30 wounded, and operated continuously for 6 weeks without proper facilities, adequate parts inventory, or predictable supply support. During that period, they maintained operational readiness for over 400 vehicles spread across 3 divisions, conducted emergency repairs on more than 200 trucks and half-tracks, and fabricated replacement parts for equipment ranging from rifle bolts to tank tracks. Their work was invisible to the combat units they supported. It was invisible to the headquarters staffs planning operations dozens of miles behind the lines. It was invisible in the historical record, which recorded divisions and armies and the movement of front lines, but rarely acknowledged the mechanics who made that movement possible. Yet without them, the counteroffensive would have stalled. Patton's Third Army had relieved Bastogne on December 26, but relief meant only the opening of a narrow corridor through which supplies could reach the encircled garrison. The real battle was logistical, re-establishing supply lines through terrain where every road was contested, every bridge was damaged, and every fuel dump was a target for German artillery. The success of that battle depended on trucks, thousands of trucks, moving constantly, carrying ammunition forward and wounded rearward, operating in temperatures cold enough to freeze diesel fuel and crack engine blocks, maintained by men working in open fields under tarps, without heat or light or the proper tools, keeping the machines running because stopping was not an option. The carburetor that Kowalski fabricated from German scrap and American ingenuity was one small component in that vast effort. It kept 3 trucks running. Those trucks carried supplies that sustained 1 convoy. That convoy supported operations for 3 infantry divisions advancing toward the German border. The chain of causation was long and diffuse, impossible to trace with precision, but the outcome was measurable. By February 1945, American forces had pushed the Germans back to their starting positions and were preparing to cross into Germany itself. The offensive that was supposed to shatter American logistics had instead demonstrated its resilience. The supply system had been disrupted, stressed, nearly broken, but it had adapted, improvised, and continued functioning. This was not the narrative that German military doctrine had prepared for. German planning had been built on assumptions rooted in European experience, that modern industrial warfare required vast material stockpiles, but also rigid organizational structures, that armies functioned through hierarchical control and standardized procedures, that disruption of supply lines would create paralysis because individual soldiers lacked the initiative or training to adapt without orders. These assumptions had proven accurate in previous campaigns. Poland, France, the Low Countries all had possessed modern armies with mechanized equipment and organized logistics, and all had collapsed when their command structures were disrupted and their supply lines severed. The German theory of blitzkrieg was predicated on creating precisely that kind of systemic shock, overwhelming enemy forces not merely through tactical superiority, but through operational tempo that prevented recovery and adaptation. Against the Americans, that theory failed. It failed not because American material superiority was overwhelming, though it was, but because American soldiers did not wait for orders to solve problems. They did not wait for replacement parts to arrive through official channels. They did not halt operations because the manual specified a procedure that current circumstances made impossible. They improvised. They adapted. They took initiative at every level of command, from generals redesigning operational plans to sergeants rebuilding carburetors from scrap metal. And that initiative created a kind of resilience that German military theory had not anticipated and could not counter. There was a deeper irony in this. German ideology had long emphasized the superiority of will over material, the triumph of spirit and discipline over industrial production. Nazi propaganda had celebrated the German soldier as a warrior whose fighting quality would overcome any material disadvantage. Yet when the test came, when supply lines were disrupted and circumstances demanded improvisation, it was the German forces that proved brittle. German logistics had been designed for short, victorious campaigns. When those campaigns extended, when supplies ran low and equipment broke down, German units faltered. Tanks were abandoned for lack of fuel. Artillery fell silent for lack of shells. Divisions lost combat effectiveness not through casualties, but through the slow erosion of material readiness that no amount of fighting spirit could overcome. The Americans, by contrast, had entered the war with no illusions about the primacy of will. They understood the war as an industrial problem, a matter of production and logistics and the systematic application of material resources. But within that industrial framework, they had preserved a culture of individual initiative that made the system flexible rather than rigid. The American soldier was trained to follow procedures, but he was also trained, often through civilian experience rather than military instruction, to recognize when procedures failed and to find alternative solutions. He was part of the machine, but he was also a mechanic, capable of repairing the machine when it broke down. This was the paradox that defined American military effectiveness in World War II. An army that was simultaneously the most industrialized fighting force in history and the most capable of functioning when industrial systems failed. An army that valued standardization and interchangeability, but also rewarded improvisation and adaptation. An army that operated through hierarchical command structures, but encouraged initiative at every level. The Germans had understood the material dimension of American power. They had not understood the human dimension. The fact that the men operating the machines were themselves products of a society that built its prosperity on mechanical ingenuity and practical problem solving. Raymond Kowalski returned to Michigan in November 1945. He was discharged with the rank of Technical Sergeant, having served 3 years and 2 months, including 14 months in the European theater. He received no medals beyond the standard campaign ribbons issued to all veterans of the Ardennes and Rhineland campaigns. His service record contained no mention of the carburetors he had fabricated or the convoys he had kept operational. He returned to his father's garage in Hamtramck and resumed the work he had been doing before the draft, repairing automotives, fabricating parts when necessary, solving mechanical problems through skill and experience, and the kind of practical knowledge that came from understanding machines not as mysteries, but as comprehensible systems built by humans to serve human purposes. He rarely spoke about the war. This was common among veterans of his generation, men who had witnessed the industrial scale of modern combat and returned to civilian life with no desire to relive or romanticize their experiences. When asked, Kowalski would say that he had been a mechanic, that he had repaired trucks, that it had been cold and miserable, and he was glad to be home. He did not describe the 16 hours spent fabricating carburetors. A carburetor from German scrap. He did not explain the calculations involved in adapting incompatible parts or the satisfaction of hearing an engine start after hours of meticulous hand-fitting. These were technical details, he believed, of interest to no one except other mechanics, and even they would understand without explanation because they had done similar work in different circumstances, solving problems through improvisation because that was what mechanics did. The carburetor itself, the first one he built, the prototype that proved the concept viable, was not preserved. It remained installed on a GMC truck that was rotated through various supply units before being returned to a depot in France, where it was either rebuilt with standard parts or scrapped as the war ended and military equipment was surplused or destroyed to avoid flooding civilian markets. No photograph exists. No technical drawing was ever made. The object that represented a small but meaningful triumph of human ingenuity over material limitation disappeared into the vast machinery of demobilization, leaving behind only a brief mention in a company log and the memory of a few men who had been there. But the principle it represented did not disappear. The principle was this: that freedom, in its most practical sense, meant the capacity to solve problems without waiting for permission or instructions, to adapt to circumstances through intelligence and skill, to maintain function even when systems failed. This was not freedom as abstraction or ideology. It was freedom as tangible capability, the ability of individuals to exercise initiative, to take responsibility for outcomes, to improvise solutions when official procedures proved inadequate. And it was this form of freedom, more than industrial production or military doctrine or strategic planning, that had allowed the American forces in the Ardennes to absorb catastrophic disruption and continue functioning while their opponents, bound by more rigid hierarchies and less flexible cultures, collapsed under equivalent strain. The Germans had understood American material strength. They had counted tanks and aircraft and calculated production rates, and they had recognized their quantitative inferiority. But they had believed that material could be countered through tactical skill, operational art, and superior fighting spirit. What they failed to understand was that American material strength was not merely quantitative, it was qualitative, rooted in a culture that treated machines as tools to be mastered rather than systems to be obeyed, that trained soldiers to think as well as follow orders, that rewarded initiative even when initiative violated procedure. This cultural dimension could not be quantified in intelligence assessments or countered through tactical excellence. It was woven into the fabric of American society, expressed in 10,000 small acts of improvisation across battlefields from Normandy to the Rhine, and it proved decisive in ways that no single battle could be. In the end, the Ardennes offensive failed not because German soldiers lacked courage or German commanders lacked skill, but because the German understanding of modern warfare was incomplete. They had mastered the art of rapid mechanized advance, but they had not understood the science of sustained logistics under disruption. They had celebrated willpower and fighting spirit, but they had not cultivated the practical problem-solving culture that allowed American forces to maintain effectiveness when plans failed and systems broke down. They had built a military machine of great sophistication, but they had not understood that the greatest strength of their opponent lay not in its machines, but in the men who could keep those machines running with wire and scrap metal and stubborn ingenuity. On a frozen field in Belgium in January 1945, one mechanic with a hacksaw and a hand drill had demonstrated this truth more clearly than any strategic analysis could. He had taken incompatible parts from different nations' industrial systems and made them work together. He had solved a problem that official doctrine said required replacement parts and proper facilities. He had kept trucks rolling when the system said they should stop. And in doing so, he had embodied a form of resilience that was quintessentially American. Practical, improvised, uninterested in theory or ideology, focused entirely on the immediate problem and the tools available to solve it. The carburetor held. The engine ran. The convoy moved forward. And the war, which had always been a contest of industrial systems and human endurance, continued its slow grinds toward conclusion, sustained by 10,000 similar acts of improvisation performed by men whose names would never appear in history books, but whose work made history possible. This was the truth hidden in the frozen forests of the Ardennes, in the maintenance half-tracks parked along muddy roads, in the hands of mechanics working by lamplight under canvas tarps. That victory was not determined by grand strategies or heroic charges, but by the quiet accumulation of small successes. Carburetors rebuilt, axles welded, engines coaxed back to life. That modern war was won not by those who planned most elegantly, but by those who adapted most effectively when plans failed. That freedom, in its most essential form, was measured not by political systems or national ideologies, but by the capacity of individuals to solve problems, to take initiative, to keep the machines running even when the manual said it could not be done. Raymond Kowalski understood none of this in grand terms. He knew only that trucks needed to run, that parts were unavailable, and that he possessed the skill to fabricate what could not be requisitioned. He did his job. The trucks ran. That was sufficient. And in the vast accounting of the Second World War, in the balance between material and will, between system and improvisation, between rigid doctrine and flexible adaptation, that sufficiency became decisive. Not because one carburetor changed the outcome, but because 10,000 similar acts, performed by men across every maintenance company and supply unit and repair depot, sustained the momentum of advance when momentum should have collapsed. They kept the system functioning. They proved that American strength lay not only in what factories could produce, but in what soldiers could repair. And in doing so, they won a victory that was invisible, unglamorous, and absolutely essential. The victory of practical ingenuity over material limitation, of human adaptability over systemic failure, of the ordinary competence that, multiplied across
millions small emergencies, became the foundation of strategic success. The snow returned that night, covering the field where Kowalski had tested his improvised carburetor, erasing the tire tracks and footprints, settling over the war with the kind of indifferent silence that followed all human struggles. The convoy moved forward, the front lines shifted, and somewhere in the darkness, another truck broke down, and another mechanic opened his toolbox, and the work continued without pause or recognition, as it always had and always would, for as long as machines broke and men possessed the skill to repair them.